Most portfolio managers still rebalance manually, pulling position data, calculating drift, and placing trades by hand. That's slow, error-prone, and introduces emotional bias into execution. This AI trading automation blueprint wires together a fully automated portfolio rebalancing pipeline that handles the entire cycle without human intervention. The system pulls live position data from a brokerage API, passes it through an LLM trading decision layer to evaluate drift against target allocations, and executes rebalancing orders based on configurable risk thresholds. The stack includes Alpaca API for brokerage execution, OpenAI for structured decision logic, Supabase for trade logging, and Slack for human override alerts. Data flows in one direction: fetch, reason, decide, execute, log, with every step auditable and reproducible. Step 1. Authenticate with the Alpaca API using paper trading credentials first and pull current positions via the get/v2/positions endpoint. Step 2. Fetch your target allocation model. Store it as a JSON object in Supabase with fields for ticker, target weight, and drift tolerance threshold. Step 3. Calculate the current weight of each position by dividing its market value by total portfolio value, then compute drift as the absolute difference from the target weight. Step 4. Pass the drift report into an OpenAI GPT-4o prompt using a structured output schema. Enforce a JSON response with fields for action, ticker, quantity, rationale, and confidence score. Step 5. In your prompt, instruct the model to recommend buy, sell, or hold for each position, and to refuse action on any ticker where confidence falls below 0.75. Step 6. Validate the structured output against a Pydantic schema in Python before any order is submitted. This prevents malformed LLM responses from reaching the brokerage. Step 7. For positions flagged as actionable, submit market or limit orders via the Alpaca post v2/orders endpoint, parameterized by the quantity field returned from the LLM. Step 8. After each order submission, write the full decision record to a Supabase table, including the LLM rationale, confidence score, order ID, and timestamp. Step 9. Wire a Slack webhook to fire anytime the LLM confidence score falls between 0.60 and 0.74, surfacing a human review request with the full trade context embedded in the message. Step 10. Schedule the entire pipeline using a cron job via GitHub Actions or a make.com scheduled trigger, set to run at market open daily or at whatever cadence your strategy requires. The most common failure point is stale position data. If the Alpaca API returns a cached snapshot during high volatility periods, drift calculations will be wrong. So check response timestamps and add retries with exponential backoff. Also watch for LLM hallucination on tickers not in your portfolio. Constrain the model's output strictly to the tickers present in the input payload and reject any response containing an unrecognized symbol before it reaches the order router. To extend this blueprint, swap Alpaca for interactive brokers using the IB in Sync Python library for access to a broader instrument universe, including options and futures. You can also layer in a risk management node before order execution, pulling VIX data from a market data provider and suppressing all trades when implied volatility exceeds a defined threshold. All tools and documentation referenced in this build are linked below. If this breakdown was useful, hit subscribe. We publish new automation blueprints every week.